Hello guys, welcome back to my YouTube channel. This is Rohanar. Today we are going to see the concept of VLSI fabrication process, a complete journey from a silicon to chips. VLSI fabrication is a complex multi-step process used to create integrated circuits, commonly known as chips. These chips are the brains of a modern electronics, powering everything from smartphones to supercomputers. First, let us see wafer preparation. Wafer preparation can be done in four steps: crystal growth, slicing, polishing, and cleaning. Crystal growth: high purity silicon crystals are grown using the cryocrylic method, forming cylindrical eggnogs and slicing them. The eggnog is sliced into the thin wafers, typically 0.5 to 1 mm thick, using diamond coated salves, and will later polish it. The wafers are polished to create a perfectly smooth surface free of scratches or imperfections, and will later clean it. The wafers undergoes or rigorous cleaning process to remove any contaminants that could affect the fabrication process. The next step is oxidization, thermal oxidization, wet oxidization, and dry oxidization. Thermal oxidization. The wafers are heated in a furnace with oxygen, forming a layer of silicon dioxide SiO2 on the surface. This layer acts as an insulator and helps to define the pattern of the circuit. Wet oxidization. The wafers are exposed to the steam at a high temperature, resulting into a faster oxidization rate. And dry oxidization. The wafers are exposed to the dry oxygen at a high temperature, producing a slower but more uniform oxide layer. After wafer preparation and oxidization, let us come to photolithography. I will explain the photolithography in terms of 3 points: photoresistant application, its exposure, and its development. A photosensitive material called the photoresist is applied to the wafer, coating the surface evenly. After it will add exposure. The wafer is exposed to the ultraviolet UV light through a mask containing the circuit design. The photoresistance is either hardened or removed in areas exposed to the UV light. And development: a developer solution removes either the exposed or unexposed photoresistance, leaving the desired pattern on the wafer. Yeah, after photolithography, let us come to the process of etching. We have two types of etching: wet etching and dry etching. Wet etching: a chemical solution is used to selectively remove the materials from the wafer, creating the circuit pattern. Dry etching: a plasma is used to etch the wafer, offering greater precision and control over the etching process. This method is ideal for creating a complex features with high aspect ratio. Yeah, doping. Doping involves diffusion and ion implementation. Diffusion: impurities are introduced into the silicon wafer by heating it in a furnace containing the desired dopant. This process alters the electrical conductivity of the silicon. Ion implementation: ions of the dopant material are accelerated and implanted into the silicon wafer, creating a precision doping profile. Yeah, after doping, we will do thin film deposition. We have majorly three methods of thin film deposition: sputtering, evaporation, and CVD. CVD means basically chemical vapor deposition. Sputtering. Description about it: a plasma is used to bombard a target material, causing atoms to be injected and deposited onto the wafer. That is known as sputtering. Evaporation: the target material is heated to a high temperature, causing it to vaporize and deposit onto the wafer. That is known as evaporation. CVD means chemical vapor deposition. Gaseous reactants are introduced to the wafer where they react and deposit a thin film. This is known as CVD. Our next process would be CMP, chemical mechanical polishing. Chemical mechanical polishing involves planarization, abrasive slurry, and precision control. Planarization: CMP removes the material from the wafer to create a flat surface, ensuring that all layers are aligned and interconnected correctly. Abrasive slurry. A slurry containing a abrasive particle is used to remove the material from the wafer surface. And precision control. The polishing is carefully controlled to ensure the correct amount of following material be removed, preserving the integrity of the circuit features. Yeah, now let us go to our next process, metallization. It contains basically two steps, interconnects and contact pads. Interconnects. Metal layers are deposited onto the wafer, forming the electrical connection between the various components of the circuit. Contact pads. Metal pads are created on the wafer surface, providing a connection point for external components and testing. Our final step would be packaging and testing. After fabrication, the ICs are packed in a protective enclosures providing a mechanical support, electrical connections and thermal dissipation. Rigorously testing is performed at each stage of the process to ensure that chips meets the performance specification. Thank you for watching the video till end. Please like, share, subscribe to my YouTube channel for further more contents.